This is one building which we won in a competition, the Velodrome for London 2012, and we worked on for 2 years, and then was built 1 year ago. So I'm going to tell you in great detail the story behind this one building. I'm going to skip very quickly through the first slides, which are about urban issues, which Peter and Mark have already covered. Just to say, this is the slide Peter showed. The people are celebrating in a double fashion, one for winning the Olympics and the other for beating the French, which is a British sport. The challenge, the Olympic Games, the eyes of the world are upon you, the world's biggest event to organise, and then 2 weeks later the Paralympic Games. Quite a challenge. A complex organisational structure reporting back to the IOC, a very complicated client. The site, as described by Peter, before the Olympics, the scar, and this great diagram about how the Olympics could stitch back together the East and the West. My talk really starts here. I gave a talk on the Velodrome and the sustainability of it to a group of 8-year-old children, and one of them said to me, but the Olympics aren't sustainable because you build it in a different country every 4 years. And they were absolutely right. These are previous Olympic Games and what's happened to the Olympic Park. And I think the 2012 bid was very good in that it turned the whole process backwards and looked at what you would have afterwards and made it work for the Games. And that was very much our philosophy on the Velodrome. So 2 slides, the Games and afterwards. Not much difference between them visually, but in terms of thinking, it's been an enormous difference. So, that was the site before we started. Dumping ground, contamination, high levels of pollution. So, the Olympic Delivery Authority was the client. They were organising all the venues. The venues were designed by different architects and pretty much worked in isolation. A large amount of demolition, compulsory purchase, and the power lines which were above ground needed to be taken down to make a site, and they were all buried beneath the ground. The sort of thing that frankly would never have happened had you not had the Olympics and the budget and the focus and the drive to make it happen. All the soil from the site was washed, recycled and reused on the site. It wasn't just taken away or buried underground. Again, a massive undertaking, and the teams all worked together to share the fill. This is the site of the Velodrome. This is a road that runs out of London called the A12, and on this site was an old cycle circuit from the 1970s where various riders had come and ridden, very hidden, very popular with cyclists. And this is a nice diagram. This is the tradition, a Victorian one really, of large parks in London. And this is what the Olympic Park will be, the first major new park for about 100 years in London. And that really will be the main legacy of this Games. So we looked at all the previous velodromes since 1948. London had the Olympics in 1908, and it had them in 1948. And so we tracked from London 1948, which has an open-air velodrome, all the previous 16. Half of them are now destroyed. And the reason is, unlike football, cycling doesn't make any money. It costs money to run a velodrome. It's indoors, it's heated, it's an expensive operation. So that really got us thinking. We didn't want this thing to fail afterwards. So we came up with this strategy, which was to say, I don't know if this will make sense in your language, that the Olympic Games is a house-warming party. In other words, it's a party to celebrate your new house. Actually, you're much more interested in the house for the next 50 to 100 years than the party. The party's just one night. But we kept this in our minds all the time. We'd design it for afterwards and convert it for the party, which is the Olympics and the Paralympics. The brief we had from the client already had this idea of the future in mind, the legacy as we call it. So this was a plan for the Olympics, a velodrome, a 250-metre indoor track with 6,000 seats, a BMX arena with temporary seats, and all the facilities you need in the Games to make it work. Afterwards, the velodrome would remain, exactly the same, a 1 mile road circuit for cycling on, and a BMX, and then new housing would come round about. So this would become a cycle park. Prior to winning the Olympic bid, there had been a plan to put a big cycle park on a massive area, about half the Olympic park. So the cyclists were very excited about this. In fact, when we won the games, they were disappointed because they were going to get less cycling and more of other sports. So we had a lot of convincing to do. We started to look at the other velodromes from the last 4 major Olympics, and it's interesting, they're not standard things at all. In Atlanta, which was the games that was done very cheaply, very commercially for the first time, they built an outdoor track out of segments of plywood and used that. Not great for cyclists because you have the wind and the change of pressure, very cheap. Sydney built a building, Athens put a building on top of an old track but didn't enclose it, and Beijing built an enormous Chinese hat. And all of these were standalone objects, very disconnected from what's around them. The 1948 arena in London still exists, and it's outdoors, and here are 20,000 people standing around the outside of this cycle track. It's a bit bigger. And we loved this image. We thought the connection between the outside, the inside, the spectators is what we should be trying to emulate. It's also interesting because, as Peter said, the Olympics are not sustainable at all. This is 1948. There's no HD TV, there's no high-level lighting. That is efficiency. In fact, one of the cyclists cycled 100 miles home after his event, so we can't really compete with that. So this was our concept, which was to build this very technical indoor arena, but make it connect to the outside and relate back to London. And so, taking the idea of the party and the house, we actually worked on the whole design for the Velo Park before we designed the building. We put in the 1 mile circuit, we made it cross a river, built it into the landscape, put a BMX course here, and then had about 7 kilometres of mountain biking in the centre of London, which is fantastic because London is a city of about 8 million people, and cycling there is very, very popular, but also very, very dangerous. We have problems with obesity, with asthma, congestion. It's a fantastic time to get people on their bikes, but we need less cars and more bikes for that to work. So an opportunity here for young people to learn to ride bikes. So we work very closely with the landscape architects working on the park to integrate all of these features, to work with the other venues, to make it work before the games and afterwards. This was a model that studied the topography of the road circuit. So, here's 3 slides which show that process very simply. Here's the map before the Olympics, 2007. Here's the map of the Olympics. The pink areas are the competitive venue areas, and the green is the park, already established. And then, several years later, when it's all been built up, the velodrome will sit with the cycle park here, but be integrated into this new part of London. Working on an Olympic project is a massive challenge. There's so many people involved. It's very hard to work out who your client is. And one evening, in desperation, I got my book and tried to work out, God, who are we actually designing this building for? And I wrote down all the people we had to report to and discuss and get approval from. And then I realized I hadn't written cyclists on the list. So the bureaucracy is quite a challenge. But the one thing that keeps everybody focused is this incredible deadline. And I think without that deadline, we'd still be in the first meeting now discussing what it's all about. So if you ever bid for one of these games, I think it's a fantastic opportunity to make things happen. Regardless of the sport, it actually makes stuff happen. So, how do you focus on this amazing opportunity to design an Olympic venue for a sport? Great Britain is a fantastically successful track cycling country in the last 10 years, and yet we don't have an indoor velodrome in London. Most people have never seen a track or a race, and yet we're the best cycling country in the world. So it's an incredible level of interest in the sport in London. I showed an architectural critic the velodrome, and he said, yeah, it makes real sense, because he'd been to see the Tour de France, he waited an hour, the cyclist went past in 20 seconds. He said, yeah, this is really clever. I sit still and the cyclists keep going past me. And that's about it. So all the focus is on the track. The cyclists go around in the same direction as runners on a running track. And we took the 6,000 spectators and we put half of them very tightly around the bottom of the track, very close, like the photograph of Herne Hill, 1948. We then made a concourse where you could walk round and either look in or look out. And then we took the other half of the seats and put them up in the roof. So we have this ribbon of glass which breaks the building in half. Very important for connecting inside and outside. And this was our very elemental image from our competition, where half the seats are in the base, there's a ring of glass, and the other half of the seats are in this roof, which we didn't know at the time what it would become. That developed, we managed to get a bit more space, we could make the sides stick out a bit more. And we honed this down very finely. Here you see half the seats, here's the track, here's the other half of the seats, here's the ring of glass. Sometimes there's accommodation here, and it all sits on this structure. That is the shape. Here you see the ring of glass with views in. And the really exciting thing about this was that a child in the East End could be in the Olympic Park in the future, walk up to that glass and look in and see the GB cyclists, the British cyclists training in there. So that's incredible connection between the inside and the outside in terms of the local community. But we wanted to do more than that. We wanted to take the idea of sustainability to the absolute highest level we could. And we looked at the bicycle. This is one of the competitive bikes from the British team. And we thought, if you could make the architecture and engineering of a building as efficient as a bicycle, that would be something incredibly exciting, and who knows where that would take you. So we didn't want in any way to copy what was on a bicycle. Beijing had decided its roof would be like a bicycle, but it doesn't make any sense on its side. We wanted to take the philosophy of the bicycle, where everything is working, everything is minimal, and every component is designed right down, honed down to the absolute perfection. And if it's not doing anything, you remove it. So we set off on this ambitious path, not knowing where it would take us, in good faith that, rather like the bicycle, it would be beautiful at the end, because somehow form will follow function with a bit of steering. It's a large building. Large buildings respond to the laws of physics, and the laws of physics tell you that in terms of a long span structure, efficiency and weight, you want to put curvature into the shape. And roughly speaking, a doubly curving shape is way more efficient than a flat or arched shape. So, could we strip out so much material from the roof, which has to span 130 meters, that it's really like a gossamer thread? The other thing really to note is that lots of people are doing complex curved buildings at the minute. I'm not quite sure where they get their inspiration from, but the challenge always comes in actually making them, because our manufacturing process is like rectilinear products. So it might be one thing to shape this building exactly to the minimum shape, but how are we going to make it? How are we going to make all of those curves? Well, what we did is we took the diagram I showed you. The model before was this shape here. So here's the track, which is at 12 degrees. Here's the seats and the glass. This is the high point of the roof. Most of the spectators are looking down on the straight, so get a good view. We then suspend the roof across here like a suspension bridge. But through the other direction, we don't have so many spectators because the track is so steep at this point. It's 42 degrees, so there's no seats high up. So over here we bring the roof right down as tight as we possibly can. So we have this complex double curvature. In fact, when the building came out, everybody called it the Pringle, because it's the same shape as a hyperbolic paraboloid or a Pringle. And going back to the image of the saddle, how do you work out the rational geometry so you can actually make this thing and make it efficiently and cheaply and quickly? Well, we took the roof off a torus, so it's doubly curving. Here it is again, radiused in that direction and radiused in this direction. Here's the roof. And then the bowl we made from a series of conical elements which all intersected together. And when you're working on these projects, the government never ever want to admit how much it costs. They start off with a number that's so low it will be impossible to do the Olympics, but they daren't go to the press and say how much it's going to really cost. So all the time you're under enormous pressure to make the building cheaper, 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 but still beautiful and sustainable. And the way we got around this was we never ever talked to the client about aesthetics or beauty or anything like that. We just talked about efficiency. We took the bicycle analogy and talked about, if you like, speed and weight. So these were different versions of the scheme, from the competition model up to almost the final one. And we analysed how big everything was, how heavy it was, and in a way this sums up at the bottom the amount of steel in the building. So it went from 1,600 tonnes to 1,000 tonnes. So we got out 60% of the steel weight by refining the design down. And that's not just steel, it's money, but it's also carbon. And so following the idea of the bicycle and its efficiency, this really was the evolution of the bicycle. And so in terms of money, it's just a comment from the person in charge of finances on the project. Really, this notion that everything that's engineered you need in the building, and people in charge of money regard architecture as extra expenditure. Well, if we could prove the architecture and the engineering are one and the same thing, we could win the argument. This is a diagram of the structural system then. Here's where the track will go. Here's a large concrete slab, an enormous amount of foundations because the ground had been so contaminated. It had been a tip, in fact, a refuse tip for about 50 years, so it's a terrible site to build on. And then here is what we call the roller coaster that went around the back. We actually found a gas pipe from America pretty much on eBay, and the contractor bought that and welded it up for the track at the back. This was all made from precast concrete with recycled aggregates and fly ash. And then the roof. Here you see this is the roller coaster shape. You get this idea of the Pringle, the double curvature. 48 of these sections all welded up, brought in and bolted together on site. Here's the concrete units going in. And so for the roof structure itself, rather than use beams or trusses, which you would normally do, normally on a building this size you'd have trusses about 10 meters deep. We would look to build it out of cables. They're 36 millimeters in diameter, incredibly fine. This is them in the factory in Germany. They lay out the cables and then they stretch them to take out the elasticity and mark exactly all the intersection points. This then comes to site with a load of German operatives who are very good. They bolt all the cables together on the ground, lay them over the seating here, exactly within 2 millimeters of where they should be. This is a European problem because British steelworkers work to maybe 50, 100 millimeters accuracy, and the Germans work to 2 millimeters accuracy. So we had a few arguments over that. So this is all laid out. Here you see a bit of London snow. They start to tension it up and pull this net into place. And what's fantastic about this system is there's no scaffolding, there's nobody working at height, it's very safe, very quick, very efficient. The blue is a net, a safety net, which is already in place underneath. It's just a quick movie of this thing going up. It literally went up in a day and was pulled into place. Amazing thing to watch. It took longer than that to draw it. See, the sun does shine in London sometimes. So you get the idea. And then this is the famous gas pipe. Here's the connections around the edge. And when that cable was pulled almost into place, it was locked off here and bolted. This was the only scaffolding we had to put on. It was just a handrail for safety around the edge. And here you see the cable net pringle fully formed. You get this idea of the curvature, the shape very clearly from that. This is where the roof lights will go. Here's your 36mm cables, and this is about 3.6 meters. So, if you remember 1972, the Olympics in Munich, they had the most wonderful Frei-Otto cable net structure. So we'd only really got back to that point here. I mean, that was a design 40 years old now that still looks amazing, but it only had a perspex cover on the top. It wasn't enclosed. We needed this building to perform at very, very low cost in the future after the games, so it needed to be very heavily insulated. We have 300mm of insulation on the top, so we needed a solid roof on the top. And the real innovation, if you like, was finding a way to put solid panels on the top. And the way we did that was through devising this node that would allow the movement of the cable net to come into the solid panels. It's too complicated to go into great detail now. But it was made from steel that had been stamped, that was clamped onto the cables, and then 4 panels would fit onto the corners. Here you see it clamped onto the cables, and these various fittings allowed the panels to move. And we had a series of wooden panels here, 1,800 of them, slightly different sizes, as you might imagine, because of the curvature. And then the insulation on the top, and then a metal roof on top of that. So these panels were all made in the factory, just simple wood, plywood, pre-made with some waterproofing on the top. They were lifted off a lorry and then dropped onto these nodes like this. I've now got a movie, but I made it on my telephone, and you're going to have to look at it on its side, I'm afraid, because if it's not on a Mac, a PC turns it on its side. This is one of the panels being lowered into place. Here's the safety netting. Okay. No, you go back one. Okay, if you just click on it with the mouse. Yeah, thanks. There you go. So here's one of the panels just lowered in. We had to number them all, we had to orientate them, because they varied by about 5mm to make sure they fitted in. Working out the tolerances was incredibly complicated because the cable net moves when you put the panels on. Anyway, they just came in and they dropped them on, and I think out of 1,800, only 10 of them didn't fit. There we go. And then they had to be fixed down, and again on its side. He just puts the bolt in and then puts a torque wrench on to calculate the correct amount of strength in the bolt, and that's how the pieces were fixed on. So in a way it was very simple materials, fairly straightforward process in a way, but lots of thinking time to make it work. And I think it's a kind of good model for how architecture should be, using sustainable materials, using as little material as possible, making it very efficient, but putting your effort into making it elegant. So this is the inside. This is one of those panels with a plywood finish. Here's the cable net. And here you start to see the final effect inside before the roof lights went on. And then when the roof came up to meet the edge, we had a very complicated detail as you followed this roller coaster around. And we made those rather like making a wooden model of an aeroplane out of a series of segments, which we made flat and then clipped onto the edge frame. And again, going back to cost, there's only about 2 things, I think, in the whole building that are curved. One is this beam around the edge, and the other is the cycle track. Everything else is made out of flat sections. Here's a mock-up of one of the pieces. Here they are arriving and being bolted onto the outside of the ring beam. This is where the gutter would go. Here you see the East End of London. And they're relatively simple technology, and you start to see these facets. This is the sharp edge of the building. And then you see how important that is to the kind of crisp appearance of the whole thing. So the cables are spanning across there. These cables are holding it down from the wind fluttering it. Here's the roof lights. Here's metal on the top and the wooden cladding and the ring of glass. So the park literally goes right up to that glass. The other kind of big idea we had in terms of efficiency was, after this notion of the bicycle, could we shrink the building, rather like the lycra on the cyclist's thighs there, stretch it as tight as we could, so we would not make the building any bigger than it needed to be. So we put a lot of effort into making it as small as we could. And that meant that this point here was as low as it possibly could be, and this point was as low as it possibly could be to make the structure and seating work. And what that meant was that there was a connection between the outside and the inside, because the seats are tight around the track and the envelope of the building is tight around the seats. And that helps us pick up the shape of the track in the shape of the building. So it clearly is a cycle venue, very dynamic, very exciting, hopefully. And the outside walls were made in a similar way to the roof. We prefabricated them and bolted them on. And that was all very good, except the guy having to make the mechanical systems had very little space. He had to fit all his equipment in this area here. Here's a picture of the pieces going on. It is actually a very big building. And the real challenge is, and this is why 1948 is no longer relevant, the cyclists like to break world records. The city hosting the games wants London, Athens, Sydney to have the world records. And the way you break world records in cycling is having a very, very hot atmosphere inside, unless you're at altitude, and maybe a slightly humid atmosphere, because the air's thinner and it takes off hundredths of a second. And the cyclists, when they're training, will literally have a laptop. They'll tell you the temperature and the humidity, and they will balance their time against world records like that. Amazingly sophisticated. What a nightmare, though, because they would go around at 30 degrees centigrade. They're going at 50 kilometers an hour. They're not going to get hot. People sitting in the crowd high up will get swelteringly hot. So you had to balance all the time the need of the cyclists and the need of the spectators. And we did that not by using any particularly sophisticated means. We haven't got photovoltaics, we haven't got ground source heat pumps, we haven't got all these fashionable things that make buildings sustainable, and yet we can argue this is the most sustainable modern sporting stadium anywhere. We have good daylight, good insulation, simple heating systems and natural ventilation. And we did that by running a series of tests on the aerodynamics, on the ventilation, modelling in great detail, because we had to be sure that there wouldn't be drafts on the track, because the cyclists are very particular. They don't want it cold air or air moving around them. They want it warm, but they want static air. And we modelled all of that, modelled temperature, air movement. And we have three means of heating it. Because we have a high point on the building here, it's good for taking warm air out. The spectators can stay cool by bringing in cooler air underneath the seats. We can heat that air with some units here and warm it up if we need to. And if the building's not quite warm enough for the cyclists before the event, we can warm it up here. Other than that, there's an enormous amount of underfloor heating that you put on 2 weeks before an event to warm it up. When the guys are training afterwards for the next 50 years, you don't need that on at all. They can just ride around as though they're outside. So this can be switched on, switched off, and you're not spending money afterwards because we've got all this insulation in the top. And this is how it breathes. These slots on the outside take the air in at low level, out at high level, and these are the boosters inside. That was all coordinated with the architecture, quite difficult. But having said we're going to make the building very small, the benefit was of squeezing all this in was we saved an enormous amount of material on the outside of the building. We did a lot of work on the roof lights. Because the roof moves up and down, we had to make sure the movement of the roof would work and it would be waterproof. And we had to make sure that the daylight levels on the track were uniform. And you need about 300 lux to ride on that track normally. The Olympics say, no, we want 2,000 lux or more in every single angle at every single plane because they want HD slow motion TV, and TV designs the Olympics. And this is the building inside with no lights on at all, showing how after the games you'll be able to train on there and not use electricity to illuminate it. And then we have a whole series of lights to get our 2,000 lux for the games. They wouldn't even let us count the daylight coming into the building in London in the summer because the cameramen are going to black out those roof lights just for the games. But we said, that's madness. So going back to our first principle, we're designing it for afterwards. We put the roof lights in and we said, if you want to black them out, you come along and black them out. So you'll have the IOC cameramen will come along with black plastic and black out the roof lights. And then, I won't go into great detail on this, but it's the most efficient venue on the park. Obviously, it's tapped into a central district system, but we had to make our building as energy efficient as we could, so it made less demand on the wider system. And in fact, going back to the photovoltaics, people said to us, why haven't you put a photovoltaics on the roof? And we looked at everything, we looked at that, and we calculated that we would save more energy by putting roof lights in than putting photovoltaics on the top, because if we put photovoltaics on the top, the extra weight would have increased all the steel sizes of the cables and would have had a high embodied carbon impact on the roof, which is very lightweight, and we got far better return on the investment to put glass in and use daylight. We also have rainwater harvesting. A whole series of targets were hit with the building, and we have a system called BREEAM. I don't know what you have here, is it LEED or DIN Sustainable Passive House? Anyway, there's all these competing systems around the world. We have BREEAM and we achieved an excellent rating. And we had an enormous amount of recycled material on the job. And then the Olympic Delivery Authority ran a test afterwards to see the embodied carbon in projects. And so they compared these venues. These are 80,000 seat stadia with no roof on them. This is a 17,000 seat venue in the Olympics with sides on and 2,500 seats afterwards with a roof on. And this is 6,000 seats. So these two are much smaller and are proper buildings, so they should come out much worse. However, these graphs go up to sort of here and here. This is the Velodrome here. And if you compare it by seat, say to the Beijing bird's nest, which is up there somewhere, we have an absolute fraction of the carbon embodied in the building. And in fact, the bird's nest is, I think in terms of television, probably the most successful building that's ever been done anywhere. And what a fantastic image. But in terms of sustainability, possibly one of the worst, because the amount of steel in that is absolutely ridiculous. We looked at it and they put some photovoltaics on the top. And they said, well, you know, it's a sustainable building, we've got PVs on the top. And we did a calculation, and we said, okay, if you use those PVs to pay back the carbon from, say, Beijing to Sydney, because it's the same size building, it would take 2,000 years of those PVs to pay back the carbon overload of Beijing to Sydney. So when people talk about sustainability, you have to really watch it. They mostly talk absolute rubbish. And this is the building, a good picture after Peter's talk of it in the East End context. Really is quite a big building. Here you see the Pringle roof. And not forgetting, there's a cycle track in there as well. So I'll just tell you a bit about how that track was made. It's made from Siberian pine. It's 250 meters long. The track is 7 meters wide. There's 850 of these trusses that go around. They're all laid at different angles. And then a team of 20 carpenters took 8 weeks to install these timber laths. They're 40 millimeters by 40 millimeters. And they're nailed in by hand, one on top of the other. The lengths are about 5 or 6 meters, so they can bend them round. Here you see them going in. Has Belgrade got a velodrome? I can't think. Don't think it has it? So, do you want one? Here they are going in, being nailed in. Very steep, as you can see. And there's the final track. And then this, I think, is fantastic space, probably the best space in the building, the space underneath the track. And then 1 year ago, the track was opened and the cyclists came in and cycled around it. And they're used to these velodromes, which are boxes, all artificially lit, and they thought it was fantastic to go in a venue with lots of daylight. And then 2 months ago, we had a World Cup event, which was the test event for the Olympics in London, and it was in here with 6,000 people. Fantastically exciting, big success. One of the things we've done was we worked with Chris Hoy, who's one of the British cyclists, on the design of the venue and consulted with him, and he had 2 or 3 ideas that were really important. He really appreciated putting the crowd all the way around, because he said what happens is you normally ride down this side and all your family and everyone's cheering. You then go down this side and you have the reporters and the judges and the IOC, and they all just sit there like that, so it goes quiet. So we managed to move the press high up, so you get crowd all the way around, give some encouragement to the cyclists. He also made sure we couldn't let cold air come in through the doors. And he also got us to make sure we had a toilet underneath here so you could get to it very quickly. And there were 3 world records broken at the event, which was a big success. This is our Scottish champion cyclist. And here you see this idea about the building being shrunk very, very tightly, as small as we could. When you're on the seats at the back, you can pretty much touch the roof. We could not have made it any smaller whatsoever. And this was the other benefit, was that we could have a really lively atmosphere. So when the crowd start cheering, it's incredibly loud, very passionate. And one of the reasons why the cyclists liked it was they really felt they were in a small, intimate arena. And even the Australians gave us some praise, which is quite good, because we love having rivalry with the Australians in sport. And finally, just to say, really, it's all about teamwork. None of these things happen on your own, and I think this project was a great case for proving that when people all work together and everybody believes in it and everybody plays their part, you can achieve far more than just ploughing away on your own. And I guess that's a theme coming out of all 3 of these talks, actually. And on that note, thank you.